Good morning, good afternoon, good evening. Welcome to another edition of Ask the Product Manager Office Hours. Today we're discussing operators in Helm. I'm joined by three of my fellow Red Hatters. Karina, you know from other shows on the channel, but there's Daniel Mester here and Stefan Lemure. Daniel, I'd like to hand it off to you to kind of introduce yourself, and then you can pass it off as you see fit.
Sure. Thanks, Chris. Thanks for having me again on the stream. My name is Daniel Messer. I'm a member of the OpenShift product management team, and I'm looking after the operator framework. Stefan, over to you.
Hi everybody. I'm Steven Lemeur. I'm product manager at Red Hat, focusing on developer tools for OpenShift mainly.
Awesome.
And I guess I'll give my quick introduction for those of you who don't join me on Tuesdays. I am a product manager in OpenShift, and in true OpenShift fashion, I cover a lot of areas.
Nice.
Thanks.
Right. Yeah, so Chris, today we're looking to kind of address a very common question, at least to Stefan and me, that has been, and Karina obviously as well, that has been sitting with us for quite some time now, that we have actually made it possible for OpenShift users to use operators and Helm in a first-class way with OpenShift.
Yeah, which is
so
awesome.
And it's a famous question of, oh my God, here's this operator thing, but also here's this Helm thing. What do I do, right?
Yeah.
So
how do I make the bits work?
Yeah, exactly. So like most people that ask us are either administrators that have like both kind of chains available and want to give them to their developers.
Mm-hmm.
And then the other audience is like application developers that are looking to get their applications out into people's hands on OpenShift and provide value, right? So, and they also ask themselves, yeah, this Helm thing seems to be really common, right? And I can package all my stuff up and then it deploys. But then there's also this operator thing, which seems to be having a lot of traction, but it has actually a higher entry bar. So what do I get in that in return, right? And when should I actually write an operator, and when should I maybe just package my stuff up in the Helm chart? And who is the person who writes an operator, and who's the person who creates a Helm chart, right?
Right.
So Stefan and I are going to try to walk through today how to answer that question from the perspective of the end user getting that app, as well as from the person that owns the app, right? That wants to make it available to other people. And Karina has already covered this in her webinars and streams. And in the first bit, we want to kind of go take a look at Helm, how it works in OpenShift, and like what kind of user experience you can get from that. So I'm going to hand it over to Stefan to kind of give us a quick intro into Helm and how it's being used and how it feels like an OpenShift these days.
Stefan, before you do your quick intro, I want to point out that both of these products are like Cloud Native Computing Foundation, like embraced projects. Yeah.
Yeah, completely. So the Helm project is quite an old project in the foundation. I think it started in 2016, so already 5 years, and it has a lot of contributors. The community is widely active. There is a vibrant set of active maintainers as well on the project, which are really taking care about it with a high level of maturity. So really interesting. And there's a lot of things that are going on. And I think the belief behind Helm is helping the developer to better manage all their Kubernetes YAMLs and all their Kubernetes resources when it's time to define how an application should be packaged for Kubernetes and how it should be configurable as well. So Helm is really a package manager, which provides a better way to manage all the Kubernetes resources, such as you can define exactly how you want to package your application and how you want to make them configurable. Daniel, if you can go to the next slide. an Helm chart is basically within Helm, you have charts, and the charts are a package which consists of all your Kubernetes resources and all your manifests for your application. You also have the repository, which will be the place where the charts can be stored, where they can be shared and distributed. And you have the releases, which are a specific instance of a chart, which is getting deployed on your cluster. And how does it work? If we can go to the next slide. So you basically have the Helm chart, which are templates. So it's taking all your Kubernetes manifest, and inside of your manifest, you will have some template values. And those values will be defined in a values.yaml file, which will provide the configuration of your application. And then it takes all of that and it creates the Kubernetes resources. So how do you work with this? In general, is that, if we can go to the next slide, is that you use the Helm CLI. So you can take a chart and provide the different values for all the configuration option of your application, or you can go to the OpenShift console where you will have a UI where you can see all the different options as well. And then Helm will create the resources and on your namespace, and then it will pull the images from the different repositories that you have. So that's how Helm is working. As you can see, it's really a convenient way to package your application, to make it templatable and to make it configurable when you want to install it. So let's actually give a look of how you can do that. So we can go into a quick demo. So I'm going to share my screen and hopefully this will run properly.
Screen sharing dance.
Yeah, you should be able to see my screen.
Yes.
Is it visible? Yeah.
Yes.
Cool. So here in this demo, I have created a very basic microservice. It's a stateless microservice that is just sending an email from my SMTP server. So it's a Quarkus application, and it's using the mailer tool in order to help me sending the email. It's using some environment variables so that it knows what is my SMTP server and what are my credentials. And usually this is not something that I want to share with my microservice, obviously.
Yeah.
So what I would like to do with this microservice, once I have it running on my laptop, once I know that it is running properly, is that I want to package it and I want to share it with the rest of my team so that if they want to use it or if they want to reuse this microservice or deploy it, then they can do it in an easy way and they can configure it the way they need. So in order to help me into this application, what I did is that I use Gcube. And I think there was a presentation about Gcube few OpenShift TV session ago.
A while ago, yeah.
Yeah. So I will not go into the detail of Gcube, but honestly, it's super easy. I just had a dependency to it in my pom.xml file, and I have Gcube there, and it gives me a wide collection of build commands and goals that I can use just to help me generating the Kubernetes resources and to help me publishing on OpenShift if I want. So starting from here, what I'm going to do now is that I am just going to show you that the application is working. So I'm already authenticated on my Kubernetes cluster, on my OpenShift one, actually. And I create a new project named mailer demo. Okay, so I'm on this project. So what I did is that I use Gcube in order to generate the Kubernetes, the manifest and the Kubernetes deployment. So I have that available here for me. And now I'm just going to deploy my my application. So you will see. So I use my dev OpenShift profile. I create the OCO resource, and then I apply them, and I provide also my environment variables for my SMTP, SMTP server. And while it's doing this, so you see, it's just a Maven command, and I'm able to push my application onto OpenShift. I love Gcube. It's really magic. So here, I'm coming into my project mailer demo, and I should be able to see my application running. If my cluster is responding.
Sometimes I had this as well, and it helped to just switch to another pane or refresh the browser.
Yeah. I want to hit refresh.
Yeah.
Maybe.
Okay.
Interesting. It threw you
So,
out of the developer view. You're not back in the admin view. Interesting.
yeah, right. Here you go. So here you can
Makes
see
all the difference in the world.
So you can see the different resources that have been created, the route as well to access it. And I can click on it. I can go to the endpoint, call the REST API because it's just a REST API that I've been doing. And if I go to my inbox, hello,
Hey, look at that.
Here you go. So that's cool. That's working. So obviously, I want to go one step further if I want to share that with my team. So what I did is that I create a Gcube folder into my sources. And here in my deployment YAML, I have provide some templates for my environment variables so that it knows when it will create the Helm chart that this needs to be configurable options. And then I have a template.yaml which provides the default for each of those. But here I just provide default. Yeah, so now I have just MVN K8s resources. So it will create the resources and K8s Helm, and it will create my Helm chart. Yeah, so here I have my Helm chart, and if I go into my YAML, I can actually see that in my deployment, which has all been generated, I have a template variable, and of course this is very basic. I can go, I could do much more advanced things thanks to Helm, but here you have an understanding of what's going on. And now, if I want, I could use the Helm CLI to install my charts. So before I do that, what I'm going to do is that I'm going to remove my deployments, and I will also remove my service. Should have one service to delete as well. Boom. And here, from here, I can do Helm install mailer demo, and I can take my the archive of my Helm chart and pass all my environment variables as options for my Helm chart. Install. And that's it. So now you can see even from here that my service has been created. And you see here it's a little bit different because on the topology view, I can see that it's an Helm chart that has been deployed. So I have some more options related to my Helm chart here. And I can open it and so on. So that's cool. So I have my Helm chart. I am able to deploy it onto OpenShift, but now I want to share it. And I want to share it so that others can also consume and reuse my microservice. Cool. So what I'm going to do is that I have created a Helm chart repository. It's very easy to create one. I create it using Helm CLI as well. You can host it on GitHub, actually. So what I did is that I create an Helm chart repo, and then inside of it, I put a folder for docs where I put the archive of all my charts. But basically, the Helm chart repository is just an index.yaml file with a bunch of metadata that highlight how and what are the Helm charts. So now what I'm going to do is that I will just copy my Helm charts onto my repository. Here we go. And so this is my VS Code for my Helm chart repository. I can update from the Helm CLI. I can update my index.yaml and add one new entry for my mailer quick start, the microservice that I create. And what I'm going to do is that I'm going to push that stack onto my repo. Nice, cool. That should be here, and I can go back into OpenShift, and I can actually zoom in a little bit. And what I'm going to do now is that I will add my Helm chart repository onto OpenShift so that I can consume the Helm chart that I just create, and I can share it as well. So nice. I look for Helm chart repository. Here I will create a new resource for that. And so as you can see, the YAML, the definition of a Helm chart repository is quite easy. Just going to add the name of my repo and the URL. I hit create, boom. And now if I go back to the developer catalog, I go to the Helm charts, and I can see my repository is appearing here, and I have my charts, which is coming here. And if I click install, I will have a way to provide the configuration for my microservice. So pretty cool, pretty easy. As a developer, I can easily get going. I can have some help from Helm to manage my Kubernetes resources. And I can package and distribute my application much more easily to my teammates, for example. So that's a little bit the mindset that you have when you are a developer. It's really okay. So I package my my application. I have a nice way to manage all my YAML files to make my application configurable for others. I can also add, as part of my chart, some part of the upgrade mechanism for my application. But really, if you start to switch your mindset and start to think about how your application is going to operate and how it's going to run once you will deploy it, and have to maintain it on production, then it's starting to be a little bit short, because it will not manage the full life cycle of your application. So you will have to handle that either by hand, and it's fully possible, but it's not really a way that is automated. And on your learning curve or your adoption curve of cloud native adoption, it's not exactly the best thing that you could be probably doing. And for that, operators are providing much more advanced capability. It will help you to follow the life cycle of your application, handle the backup, the failure recovery. You can also leverage insights from how your application is behaving while it's running, to define some ways of how your application should be operate, in fact, and you can automate that with operators. And that's probably where I will hand over to Daniel, which will give you much more colors about everything that you can do with operators.
Cool. That was a great demo, Stefan. I actually haven't seen all of the Helm console in OpenShift yet, so that was really impressive to see how much of a great experience that is now also in the developer console. So
thank you.
I think what you've highlighted is that microservice example was a really great fit, right? Because when people ask me, like, when do I reach the point where I should write an operator versus staying with packaging technology like Helm, I usually give sort of an academic answer almost, where I say, if your application lifecycle, if everything your application needs to do from having it start up, be reconfigured, updated, and then eventually uninstalled or retired, can be done with core Kubernetes features, with onboard Kubernetes features like, you know, deployments, stateful sets, PVCs, services, routes, and this kind of things, then you should just stay with Helm, right? Because then the lifecycle of your application is completely in the hand of Kubernetes, right? And all the primitives that Kubernetes knows about, how to do a rollout, how to do a deployment, how to do an update, will take care of that, right? So that's why this arrow here in the graphic from Helm goes a little bit into like the seamless updates lifecycle phase, right? And when that's all that's needed for your app, if you have like a stateless microservice like Stefan showed you, then that's actually enough, right? Then that's great, right? Then Helm is the perfect tool, and I'm always for using the right tool for the right job. And you should stay with Helm, right? Because an operator wouldn't give you any kind of advantage over that, but it would be compared to packaging a Helm chart, much harder to get to that state, right? Because you need to write the operator. But the operator has essentially, as a pattern, the ability to adapt to a whole more complex and more complete lifecycle, including what happens after the day one where you installed and initially configured your application. That's where the interesting stuff happens, right? And as we see more adoption of OpenShift and Kubernetes in production, that's where also the lifetime of these workloads will get longer, right? And users and customers are asking us to provide tooling and experience for long-running critical workloads on OpenShift. So in this sense, you have questions like, how is my application updated? How does it update and migrate its database schema? How is it backed up? Is there kind of some failure recovery happening, right? How do I make the application auto-tune itself based on a certain workload pattern, right? So these are things that core Kubernetes, you know, isn't really up to right now, and it shouldn't be, right? Because Kubernetes has always been written to be a platform of platforms, and what that means is it's extensible. You can teach it new tricks to do these kind of things for your app. And the operator pattern is that, right? It's teaching your Kubernetes, your OpenShift system how to run a database over a long period of time with all these things like backup, restore, failover, failback, embedded in the logic, right? And make it something that's a first-class citizen. And at that point, usually people tell me, okay, that makes sense. But there's really no discussion anymore, right? They take away that knowledge and kind of go home and go about their things. So I thought we might need to add a little bit more of examples, right? And tangible inflection points at which you should think about as the application owner or developer. Maybe I should write an operator to cover that specific piece of my operational needs for my application, right? So that's what I'm kind of trying to show you now. So you've probably seen something like this slide for a number of times now. It's kind of the autonomy of an operator. I don't want to go into a lot of details here, but the biggest difference between what you've seen from Stefan and what you're going to see here is a Helm chart is a package way of your manifest distribution, right? So it allows you to template manifests out, and that makes up your application. And that gets your application deployment. An operator is actually a piece of software, and that's not your application that you're looking for. It's a piece of software giving you this application as a service, right? And it sits in the system on the cluster itself, and it watches for events, right? And when it does that and it sees events that it's interested in, it can start to do workflows and it can start to do automation. And one use case of that is to model application deployment in a way where an operator will introduce a new custom resource type in the system. So next to deployments and pods and stateful sets, you now have a thing called enterprise database. Oops. So enterprise database, right? That is now a first-class concept in your system. It's actually an API, a custom resource type in your system that the operator watches for. So when it pops up or an existing one is modified, the operator starts to do its work. And what this work looks like is something we call reconciliation. And that's basically saying the operator will always take a look at the left and see what's specified here. I want to have a database version 3213, size 5. And what's on the right-hand side? What's happening on the cluster? What is already there to make this request be fulfilled? And it will constantly work towards fulfilling that request in an iterative fashion, just as Kubernetes itself works, to eventually come to a state where enough deployment, stateful sets, secrets, config maps, and persistent volumes are there to have a database service running, right? And the way to do that sits in that operator, right? This custom logic, custom to this specific enterprise database, is codified in the operator, and that's a pod running in your cluster talking to the Kubernetes API. So that's something different than a Helm chart, right? So with Helm, you kind of get the application yourself. Mm-hmm. With an operator, you get a service that gives you the application, right? So the difference is really how do I get the application up and running as quickly as possible with some minor customization versus having an as-a-service experience. So the analogy I usually draw is when people want to have a database on, say, AWS, and they want to have a Postgres database. So what do? They could obviously say, here's a CloudFormation template that lays out all the resources, virtual machines, EC2 disk storage, S3 blob storage, whatever you need, and arranges it in a way so that you have at some point a Postgres endpoint running. This is the templating approach, right? This is what we saw with Helm and also what Customize and other templating tools are doing. But that's not what AWS users are using, right? What they are using is RDS, right? Is a managed service, the relational database service, which gives them a Postgres database as a service with all the high-level Postgres controls that you would expect from a database service. So an operator is really like RDS, but in your cluster, right? Wherever your cluster runs. So what you do with installing an operator and giving people an operator experience is giving them an RDS-like experience, but on your cluster, right? It's on demand and it's as a service, and people select from it from like a service catalog type fashion, right? So that's kind of already a difference in the end user experience. And if you want to have one or the other, you choose Helm or operators. The other aspect that's important to understand is like, where do things run, right? So what Stefan showed was basically running the Helm client and creating resources on the cluster. And the Helm client ran on Stefan's notebook, right? in the case of the OpenShift console, actually runs as part of OpenShift. But normally Helm is kind of an external tool that runs outside of the cluster, and that's where all the logic is, right? And the tool only runs when it's invoked, right? So either a user invokes it or some sort of GitOps methodology invokes it. And then it renders all these things and fans out the resources to the cluster, and that's when it's done, right? So it uses the Kubernetes APIs, but in a one-off fashion. A Kubernetes operator runs in the cluster, and it can be used by multiple users. So if you want to use a Helm release among multiple users, all the users need to have ideally the same Helm client, as well as the same chart version, right? Otherwise, you're going to have conflicts. With an operator, all the logic sits in the cluster. The binary that has the logic runs in the cluster and can be used by multiple users. It watches the control plane of Kubernetes, so it can see all the events that are running, and it can use this capability to get you an application or to do other things. So it's not just application deployment with Kubernetes operators. You can also use this to trigger event-based automation, or to even talk to an external API like an external cloud service, right? So if you want on OpenShift to consume an Azure-hosted managed database, you use the Azure Services Operator and its APIs to get you an instance of that. And the operator will facilitate that on your behalf using the Azure APIs. It actually deploys nothing on your cluster. All it does is reacting to your request, which you place in the cluster, and responds to that by giving you the credentials on that request, right? So that's also a different nature of running software. And the Kubernetes operator can therefore do more than application deployment. It can also automate stuff on a system. It can also use external systems to do that. And I already said that it's actually constantly doing that. So it runs in a loop, and it notices when things are changing in the system. So when your application requires you to change and react to system changes, beyond what Kubernetes automatically does with rescheduling pods and so on, then you would write an operator to watch these events and trigger custom code, right? So this might be a little bit abstract, but it's really important to understand that the operator runs all the time versus Helm only runs when you invoke it, and then it's done. You have no chance to do anything with Helm after that unless you run the Helm binary again. But if I go in and delete a part of Stefan's mailer demo deployment, like the service, there's nothing that notices that in the system, right? It's only getting restored when you run Helm again, right? And with an operator, that would be something that got recreated automatically within a couple of seconds. But maybe let's take a different look at, like, what does it mean to react to system events? So I'm going to quickly share my OpenShift cluster here, in which I have a fairly interesting operator installed that I'm really come to like. It's the namespace configuration operator, and it's something that ships as part of OpenShift's community catalog. And what this thing does is help with onboarding of new users and projects. And specifically what it does, it can watch for new projects getting created and ensure that certain things happen in that state. In particular, certain resources are by standard applied to this project. And the most common case is actually default resource quotas, right? We all know the enemy of a stable clusters are all those projects and namespaces that have no max quota at all, right? They will just gobble up all the resources in your cluster and can, create a huge noisy neighbor syndrome and an outage in worst case. So the namespace configuration operator allows me to define what should happen when a certain namespace appears. And this is done via an API called namespace configs. I created an example here. And if I go there, I can see that what it does, it lets me provide a label selector to match namespaces to which this default set of resources should be applied. And so the label selector is one called size equals small. And there is a number of objects that are always going to be applied when those resources, when those namespaces are created with that label. One is the resource quota, right? I want to limit these namespaces to max 4 pods, to a maximum usage of 2 CPUs and 2 gigs of memory and 4 gigs of ephemeral storage, right? So that should be there by default, and I should not need to make that happen manually with the admin that provisioned the project for the developer, for instance, or trust my developers that they will create reasonable resource quotas themselves, because likely they are going to throw in much higher values here, right? Developers tend to overstate their requirements to be on the safe side. The other thing that it does here, it actually configures this namespace with an egress network policy to be air-gapped, so they cannot reach the internet. This is something that is important in security-sensitive environments. So these two objects, based on the operator, would be created automatically whenever a new project is created. So let's go ahead and actually try this real quick. Let me just create a project here that's called Developer Unlimited. And this is going to be just for illustrative purposes that by default, no resource quotas or egress policies are applied when you create a project on OpenShift. This is something you should probably know about when you give OpenShift to your tenants and your colleagues, right? Because by default, they can do anything in the system in their namespace in terms of requesting resources, right? So what we want, however, is a more sane approach where by default, there are going to be some limits, right? So let's create another project. I'm just going to do this with YAML for the sake of the presentation demonstration, where I'm going to create a project called Developer Sandbox with this label, right? I'm going to hit create. And now what you see is that a resource quota has been applied automatically. And that's because the operator watched for namespaces being created in the system. And when that happened, and it also fulfilled the criteria of that namespace needs to have a certain label called size small, then it started to place these objects. So here's the resource quota. It's the exact one that we've seen before. As you can see here in the specification, it limits you to 2 CPUs at max, and it limits you to 4 pods at max, right? And developers who might want to circumvent you as an admin can also not delete that, right? The operator will just restore that as part of its reconciliation, right? And this is this event-based automation that you can do with an operator. This is not about deploying an application. This is really about making workflows happen automatically based on certain things happening in the system. And because the operator is in the system, running all the time, running in the loop, you can actually do that, right? So I could try to go ahead and delete that here. I didn't try that before, so this is a true live demo now. I expect that thing to come back. And there it is. So wow. That didn't even take a second. So this is really aggressive. So as it should be, right? This is, proper tenant isolation. So this is one use case of an operator besides just application deployment, right? So this is really useful, and it's hard to do when you're sitting outside of the system, right? This is best something that runs inside a system, watching over your cluster at all times. So that's one thing.
The power of that reconciliation loop is nothing to be sneezed at, right? Like, it is really a game changer.
Exactly. The loop nature is really what makes it a different kind of software, right? Mm-hmm. And this is also different to you writing your own like Ansible playbooks or bash scripts that run in a cron job fashion outside of the cluster. Also works, right? It's also a viable approach, but this is a much more predictable and versatile experience. Mm-hmm. So as you can see with Helm, you have a very predictable and a standardized workflow that everybody came to love, which is download the chart, customize your values.yaml, deploy the app, reconfigure it with Helm upgrade, and eventually retire it, right? And that's why Helm is super popular, because every application packaged at Helm kind of works this way. So you learn it once, and then you can apply that learning to all Helm charts, basically, right? But it also will usually not do much outside of that, right? So on the right-hand side, you see all the things that you could do with an operator, which is, of course, request the app or reconfigure it or update it, but also automate these workflows, as you've seen in the demo before, right? Or request external services like from your cloud provider, or react to cluster events, do more complex sequence things like backup and restore and failover and fail back. So it's not just day 2, it's also day 1 operations, but also integration with external systems and this automation character, right? So that's kind of what I wanted to show to you as part of different nature. Here's an additional aspect that gets forgotten, and it's especially important for maintainers of apps that want to give a great user experience to their customers, right? So if you're using Helm, your RBAC, the access that you currently have in your cluster, defines what the Helm chart can do and what Helm chart can deploy. So if you are deploying something that requires cluster admin, let's say your Helm chart creates a storage class because you're deploying a software-defined storage in your system, that would have you required to be cluster admin, right? So there's no way you can give this to an unprivileged user because Helm runs with your permissions, right? So most of the things that are packaged as Helm charts are actually therefore scoped down to be in the namespace and for user, and that's fine. But with Kubernetes operators, you have the ability to have a different set of permissions be used by your operator versus what your users need to have and what the application eventually gets, right? Remember that in Kubernetes, you cannot give more application permissions that you have yourself. So with an operator, you can come around with that a little bit because you can have unprivileged users use a privileged operator that deploys things in the cluster so that these users don't need to have those privileges, right? So it's kind of a privileged delegation mechanism that allows the operator to carry out more privileged tasks without having you as the admin give those users those privileges. And that, as an application developer, is important because I want my application to be as used by many people as possible, and I don't want people to be stuck in environments where they are not cluster admin. So that's why you have two choices here, right? If you want to do one or the other. So how does it do its job? This is where it becomes really interesting, because what we've seen with Helm is that once Helm renders the chart, it essentially throws all the resources on the cluster. This is typical Kubernetes, right? It's give me all the end state and I'll try to reconcile as long as possible until it reaches your desired state. So it's this eventual consistency, right? And it's this goal-seeking nature of Kubernetes. And for things like this microservice that we saw, or in general, stateless applications, this is just fine. They don't need anymore. And that's why Helm is so suitable for this, right? It runs once and it deploys all these things at once in parallel, and essentially lets Kubernetes do its thing, right? There's limited room for customization on how that works. There are pre and post hooks you can run to perform some basic lifecycle beyond just deploy everything, but at its heart, it's that. On the right-hand side, you have the operator, because the operator runs code. You can sequence stuff. You can do the first thing, wait for it to finish. You can do the second thing, wait for it to finish before you do the third thing, if the outcome is A, or the fourth thing, if the outcome is B, right? So you have conditional logic in this operator that enforces ordering and consistency and wait states to ensure the integrity of the application, especially over time, right? So if your application needs that ordering, then it's probably a good idea to use the operator pattern, because it's going to be at some point hard to do this with Helm. And maybe let's take a look at an example of an application stack, actually, that has some of these requirements. So you might not know this, but I'm also the product manager for something called Quay. And Quay is a registry platform. It's a container registry. And we don't need to go into details on what it does. Suffice to say, it is a Python application that has certain requirements. It needs to have a Redis database, it needs to have a Postgres database, it needs to have some object storage, and then it all comes together with a config map or a secret, which you attach to your pods running the Quay Python scripts in a scaled out way in order to get you a highly available registry. So let's say I'm the maintainer of Quay and I want to give this to you, right? So what I need you to do in order to get this up is you need to get yourself a Redis, you need to get yourself a Postgres, an object storage. And then you need to run something that we call a config editor, which is essentially a UI that generates the config file. You technically don't need this. The only thing that this thing does is actually creating the initial database schema that Quay needs to run. So when you have done all of that in order and waited for it all to be ready, you essentially then download this config file, inject it into your pods, and off you go. And depending on what features of Quay you want, if you want to have security scanning, you need to actually run a separate thing called Claire first, wait for that to be up and online, and then you run Quay. And initially, subsequently, if you want to use another feature called repo mirroring, you also run additional workers in that. So not really important what these things mean, just know that there needs to be certain things that happen in order for you to actually get the deployment. So if I would do this with Helm, this could very much and very possibly go like this, right? I go, Helm install, get me a Redis, Helm install, get me a Postgres, and then also Helm install, get me an object storage, which in this case is something called MinIO, which is a small scale object storage that's just sufficient for demo needs. And all these Helm charts are going to deploy all these things and are going to spit out some instructions on how I get to the service it just deployed, get the credentials it just deployed, I take notes of all of this and write it up, and then essentially launch the Quay config app, which gives me a UI in which I enter these credentials. So the Quay system validates that it can actually access the database or the object storage, and then it also creates the database schema. These things all need to run before you run Quay. So I'm trying to get to my config app here. Switching screen share real quick back to OpenShift. Oh, the application isn't available. Well, that's kind of typical for Helm, right? Because Helm doesn't know that the config app needs, maybe 10 seconds to come up. It doesn't wait for the pod to be scheduled. It just spits out the data and it says, wait like a couple of seconds. So if I refresh this is just going to be there. I'm not going to see a UI in which I can enter all the data, right? So this is how this could possibly go with something like Helm. And for developers, this is probably fine. But if I ship this to customers, I can count on it that 20-30% will get it wrong, will use something unsupported, or just type in the data wrong, and try to automate this. And it's kind of hard because extracting all these credentials from the Helm charts that you've just seen is a little bit manual, right? Doing that in GitOps fashion or in Ansible playbooks is kind of hard. So maybe there's a different way, right? And this different way could very much look like this, where you actually have an operator that does this for you. So let's switch namespaces here real quick. Go to Quay operator and go to the list of installed operators, and you see I have the Quay operator installed. And that thing knows how to do all of the sequencing and all of this provisioning as it's coded out. So I just go in here as a Quay registry, and it gives me a form which is generated by the UI based on inputs that the operator supports. And if I switch to the YAML view, you see it's just another Kubernetes resource, right? So if you're on the command line, you could also just do this with kubectl. And this is how I tell the operator to do something, right? I basically say, these are the Quay components that I need. I want to have security scanning, the database, object storage, yada, yada, yada. And the operator goes off and deploys all of that, right? So let's say I ask it to not give me a database because I want to have a external database, right? So I just set this to off and say create. I could essentially also leave all this out here and say, this is the config spec, right? This would also work. This just makes an all-in-one Quay deployment. So very easy to do, but let's say I want to deploy this without a database. And the operator transitions to a state where the condition rollout is blocked appears. And if you go on the resource that we just called example for the sake of the demonstration and scroll down, you see the reason. So the config is invalid because I asked the operator not to provide a Postgres database, but Quay needs a Postgres database. So the config bundle in which it would normally retrieve where's my database doesn't have this information, right? And subsequently, the operator actually stopped doing anything, right? So there are no, additional pods here. There's no additional crash looping Quay pods. It's deploying Claire, which comes with its own database here. But there are no Quay pods that are crash looping because they don't find a database. It's because the logic of the sequence I've shown you in the slide earlier is kind of hard-coded in that operator. So now as a user, what I'm actually doing is I'm going to the config app that the operator automatically created for me. And I'm now going to give it the Postgres credentials of my external Postgres database. I'm not going to do this now for the sake of time in this, in this stream, right? But that's how I would do this, right? So and that's the kind of interaction that makes it really nice for users to discover how your app works. Rather than failing hard and creating all kinds of errors, it kind of goes to a state where it's immediately clear what you need to do.
And like providing that logic inside the operator is truly a gift, right? Like you're giving a gift to folks on how you intend this operator to be used long-term and kind of, helping them along the way and not having to worry about maybe those edge cases that the operator knows about and can then maintain, if a state changes or something, it's good, right? Like it's going to put itself back into a good spot.
Exactly. So I get less support calls, right? This is what I want, right? So reconfiguring Quay is actually quite easy. You could kind of do this with Helm. Reconfiguring Quay is just updating a secret or config map and then bouncing your pods. It kind of turns out that bouncing of pods doesn't happen automatically. So if you have a deployment that mounts a config map or a secret, and that is subsequently updated, Kubernetes does nothing to your deployment, right? So Helm has a little trick under its sleeve to make the deployment bounce. And you can look this up in documentation. It's actually quite nifty. But what you do is you track a hash of your config map in the annotation of your deployment. And because this changes when you obviously update the config map, this also knows, lets Helm know it needs to deploy the declare or Quay deployments in this case. But it doesn't do that in order, right? So, but it needs to happen in order because Claire needs to be up first before Quay can start, right? And you may have other applications that have this requirement. So this is kind of doable in Helm, but it's something that the operator can just take care about in its internal logic, so you don't need to. And now comes the truly difficult bit, right? Which is how to update Quay. So Quay is a scale-out Python application over a database. So it's kind of an application stack, right? And you could have a Helm approach where you use Helm charts for all of the individual components, and then you let the user with all those individual components with different Helm releases. What the operator does, it looks at all this thing as one stack, right? So in order to update Quay, what you would actually need to do is you need to scale down your deployment to 0. Then you need to run exactly one version of your new Quay, exactly one pod. And what this will do, it will execute database migrations. So from one Quay release to another, we might actually, change fields in the database, create new tables, rename columns, and so on. So these things are automatically migrated on startup when the first Quay pod starts up, but it needs to happen without any other Quay instance or any other client really accessing the database, because they might catch some influx state of the database, which doesn't make sense to them. So you need to scale down, let the database migrations run. This may take all the way from 10 seconds to a minute. And only then, when that's finished and successful, you scale up the new Quay deployment. Otherwise, you need to roll back, right? And doing this with Helm in a single command or just within one Helm chart is extremely difficult. You would need to write a script or some sort of program that scales down your deployment and runs as a pre-deployment hook in Helm. And that needs to then finish and wait for this stuff to be scaled down so another job can run that does the database migration. It's not impossible, but at that point you are programming, right?
Right.
And if you are programming, you might just as well program an operator that does this in a very, very consistent way. So the way this is done with the operator is, at least in the case of the Quay operator, very straightforward. What you do is, if you want to update your Quay, so I have another deployment here that's already running. So if I go there, I'm just going to quickly show you that it is indeed running the version I tell you it runs. So I open the UI here. I'm not going to authenticate now, but you see it runs version 3.4.3, right? So going back here, what I want to do is updating Quay. I want to make all these DANs appear automatically. So the way I do this, I update the Quay operator and I say, you're not version 3.4, you're now version 3.5. So I switch the operator to another channel, which is like channels in your browser, so you get new versions. So every Quay version has a channel in the operator. In order to upgrade, I change the channel to 3.5. And that will make the operator lifecycle manager in Kubernetes update that operator. Mm-hmm. This triggers a little glitch in the UI where it will take like a couple of seconds to come back. But what you will see is you will have a 3.5 operator in a couple of seconds. That 3.5 operator automatically starts to migrate all the Quay deployments, right? So if you go here, you can see the Quay deployment is still there. The pods are still running, but they are starting to update, right? So this is your operator automatically updating your Quay in order, in that order that I've shown you. Scale down, run the migration, scale back up. I just had the single pod because nothing is going on in the system right now. So if I would go back to Quay, and this may take another 5 seconds or so, eventually I would see a 3.5 down there. So it's still not ready, still updating. And that's probably something we should fix in the operator to not say the old operator is gone until the new one is there. But that's kind of the in-between state that you have to accept in the database migration. But eventually it will say 3.5 down there, right? So, and that's happening automatically, right? And that happens automatically for all your customers and users. And that's how you get less support calls. That's how you make people run into less bugs, because everything is managed in the way your application needs to be managed, right? So I'm not going to wait for this year, just to continue and come to an end. So when you think about what do you want to use, you have these two choices. You also have other choices, but let's say you have the packaging part and you have the operator route, right? Packaging is very low effort, as we have seen. It literally takes one command with that Maven plugin to get you going. And you can get quite far with this already in user experience. You can make the installer breathe, and you can also do simple updates, right? So that is very low effort, and gives you some coverage in the lifecycle of your application. So you have a good consumption experience. If your app has more needs, however, right? If it is not just stateless, if it has this kind of lifecycle that I've shown you with updates and reconfiguration, if it needs sequencing, ordering, orchestration, user input, right, and conditionals, you're going to write an operator. And that initially seems like a much higher bar to meet. You need to actually, write code. You're signing up for maintaining APIs and compatibility contracts. So in order to do what Helm does, initially it's much higher effort. But eventually in the long run, if your application has those needs and you want to provide that as a service experience that we've seen before, or you want to automate workflows on the cluster, then the operator eventually gets you all the way there, right? So that kind of is some guidance on how to, navigate between the worlds.
And it also depends, as we mentioned earlier, about what kind of application you want to package. If it's very simple application, or if it's stateless microservices and things like that, Helm is a good fit. I also believe that it also depends on how much you want to automate. Sometimes it's not needed to automate everything. So
there is that trade-off, right? Like if you spend a whole day automating a 30-minute task, that's one thing. But if you spend a whole day automating a 30-minute task that happens once a week, that's going to pay off at some point, right?
Obviously, yeah.
So meanwhile, the Quay has updated, right? So it took like something like 45 seconds or so, a little bit long to a demo, but eventually it succeeded, right? And it's doing this for all the releases. So previously it has been a pain for our customers to do this because they needed to do this dance themselves. And now with the operator, we are never getting any complaints about this anymore, right?
Wow.
So that's something that you can get out of that experience, right? So now people say, when do I use what? But I think you can safely say when you're on the beginning of your application and you don't quite know how it's going to turn out and how much it actually needs, something like Helm is just fine, right? To get you going, to quickly share it in the way that Stefan shared the application. So actually, do you see the slides? It should left.
Yes.
Yeah.
So like you start with a Helm chart, right? But then at some point you realize, oh, now this thing becomes more complicated and I need to do more complicated things that I can't do with out-of-the-box Kube features. Then you can look at the operator pattern, right? And we have a project called Operator SDK as part of the operator framework that helps you leverage your existing Helm charts and put it into another operator. So that immediately gets you from just a Helm chart to an operator. It just doesn't have any more logic at this point. So that's something we aim to do and allow you to do in the future, where you will just be able to reuse your existing Helm chart in an operator, to which you then add additional code to do any of those phase 3 and phase 4 things, right? And this could be Golang code, could be Ansible playbooks. This is something we call hybrid operators, and this is something we plan for the SDK to be supporting this year. It allows you to mix and match your existing Helm charts, so your investment isn't gone there, to an operator that can truly do these more complicated things, which you would normally ask users to say, oh yeah, don't do this with Helm, do these 5 kubectl commands and off you go, right? That's kind of what we are planning to do in that sense. And that would allow you to do, to use best of both worlds, right? Use Helm for the simple deployment stuff and use the operator for the more complex orchestration stuff or the automation with cluster events or off cluster services.
And giving the best of all the worlds, like the simplicity and the ease of access of Helm to the developers is also key for the adoption and the adoption of your cloud native automation journey as well.
Right. So there are a couple of resources to follow up on this, and then if you want to learn more about both of these technologies and patterns. And I think with that, we are like at the top of the hour.
Yes, we are. And there's a few more minutes we can run over if folks have questions here. But yeah, there's a ton, like the Kubernetes operators book that was written by Jason Dovies and Josh Wood is highly recommended content, right? If you're dealing with operators, in my opinion. That book kind of cracked my brain open into the fact that like I can do this, because even though I'm not a programmer, I know Ansible and I can make, you know, a whole full-blown operators out of Ansible now. And there's some even built into OpenShift that are written in Ansible. And that's really kind of like heartwarming to me as somebody coming from the ops side, because I spent years using Ansible, and now coming to Kubernetes, it's like, where does that skill set bring me? And, you know, with the operator pattern, it could take me a long way. It's pretty cool.
And for Helm,
Yeah. Yeah. Sorry.
Find
Yeah.
everybody.
I don't have my iPad, so I can't hold up the book.
So Andrew Block and Austin Dewey, that most of you know, wrote that one. And then the Helm maintainers also have a book out. So, I mean, between the two of them and then all the other resources for Helm. I mean,
yeah, there's a lot of resources available out there. If you're struggling, feel free to drop in on our Discord at any point in time, ask your questions there. We can find some answers for you probably. And, you know, always check out the Kubernetes Slack. That's a great place to go look for answers, or, you know, find like-minded people that are doing similar things to you. Any other resources, for example, that we want to like mention?
We have these 2 pages like here on that. So like there's a ton of documentation, right? There's also a lab on learn.openshift.com for Helm. And also for operators. This is really cool because you kind of get access to an OpenShift cluster just in your browser, nothing else needed to install. So I really like those interactive labs. And then, on the Kubernetes Slack, we have the Helm channel, we have the Kubernetes operators channel, and then operator framework, which we've touched upon in this stream as well at some point, is having its own website here, operatorframework.io.
I've been dropping links in chat left and right. So yeah, can you share these slides with me so I can stick them up on our slide share at some point today? Thank you. And folks, if you're looking for the slides, I'll have them up in the next 24 hours for sure. And thank you, Daniel. Thank you, Stefan. Thank you, Karina, for coming on and showing off, you know, operators in Helm and how they can work together to extend clusters and, you know, make people's lives easier and better. You know, I don't like support calls in the middle of the night. I'd rather have an operator take care of it for me. I can programmatically do that. That's powerful. So thank you all. Thank you for tuning in. Coming up here at noon, we're going to be talking about event-driven applications with, I can't even say the name, Cogito serverless workflows and Knative. So if you're interested in serverless, check it out. And until then, stay safe out there, folks. Thank you, everybody.
Thanks, Chris.
Thanks.
Thank you, guys.